Algebra 1 EOC Star Review, Arithmetic and Geometric Sequences on page 4. We're given a sequence or a pattern of numbers, and it asks us to find the eighth term of the sequence. So an arithmetic sequence is just a sequence of numbers or a pattern that we can generate through addition. So you see this example, we would add 7 to get the next term in the sequence. So looking at our sequence, we're asked to find the eighth term. We're given 4 terms. -8 is the first term, -3, 2, and 7. So we can find what our addition is. Our pattern looks like we would be adding 5 each time. So if that pattern were to continue, we could complete the sequence of 12, 17, 22, and 27. So the eighth term in the sequence would be 27. Now this is easy if it's only asking for the 7th, 8th, 9th, or 10th term. But if it's asking for the 100th term or the 500th term, you probably wouldn't want to sit there for 30, 40 minutes adding 5 each time. So instead we use what we call an arithmetic sequence formula. So the formula is to find any nth term, a sub n, in the sequence. We can take a sub 1, the first term, add the common difference, d, what you're counting by, and multiply that by the number of terms minus 1. So back to the sequence we started with. To find the formula, we would take the first term, your a sub 1, which is equal to -8. It's the first term in the sequence. D is your common difference. We were counting by +5 each time. So the formula would be a sub n, to find any nth term in the sequence, is equal to -8, the first term, plus 5, the common difference, times the number of terms n minus 1. Find the next 3 terms in the sequence. So in this sequence, notice you might have thought add 2 each time. Well, 1 plus 2 is 3, but 3 plus 2 is 5. It's not 9. So that lets us know that this is not arithmetic, but now a geometric sequence when it's a multiplier. So here, for example, here's a sequence that is being multiplied by 2 or doubling each time. That would be geometric. So if we're going to find the next 3 terms in our sequence, we need to identify what is our multiplier. So our common ratio, we would multiply times 3. 3 times 3 is 9. 9 times 3 is 27. And we could continue that pattern. 81, 243, and 729. If it's geometric, if you're having trouble finding the pattern, a little hint may be to take a term like the 4th term in the sequence and divide it by, we can work backwards and divide it by 9. 27 divided by 9 is 3. 9 divided by 3 is 3. And that would get you your multiplier or your common ratio. What equation could be used to find the nth term? Once again, we wouldn't want to multiply 3 if it was asking to find the 300th or the second or 200 or 400th term. Okay, if there's a lot of terms that we have to find. So once again, we have a geometric formula to help us do that. It's a sub n equals the first term, very similar to how the arithmetic starts. But now instead of adding the common difference, we multiply by the common ratio r and raise that to the n minus 1. So the first term is 1 in the sequence. That's given to us right here. The common ratio was the multiplier times 3. So the geometric formula would read a sub n equals 1 times 3 raised to the n minus 1.